You're sitting at your desk, determined to finally tackle that project you've been putting off. You open your laptop, pull up the document, and for about 30 seconds, you're locked in. Then your phone buzzes. Just a quick glance, you tell yourself. 5 minutes later, you're 3 Instagram stories deep, watching someone's cat knock things off a counter. You snap back to reality, refocus on your work, and then suddenly remember you forgot to reply to that text from yesterday. Before you know it, an hour has vanished, and you've accomplished exactly nothing. Sound familiar? The uncomfortable truth is that your brain is systematically refusing to focus, and it's not entirely your fault. Something fundamental has shifted in how our brains process attention, and the science behind it is both fascinating and slightly terrifying. So let's see what's really happening inside your head when you just can't seem to concentrate. The numbers alone paint a concerning picture. Research tracking attention spans over the past 2 decades reveals a dramatic decline. Back in the early 2000s, the average person could focus on a single screen for about 2.5 minutes before switching tasks. By 2012, that number had dropped to 75 seconds. The most recent studies, 47 seconds. That's right, less than a minute before your brain demands something new, something different, something more stimulating. Scientists have been measuring this phenomenon in laboratories using everything from brain imaging to eye tracking technology. What they've discovered is that our attention doesn't just wander randomly. There's a biological mechanism at play, a kind of built-in timer that creates opportunities for distraction. Research from the University of Rochester found that our attentional spotlight dims between 4 and 6 times per second, creating tiny windows where distractions can pull us away from what we're doing. Your brain is constantly scanning the environment, asking, is there something more important I should be paying attention to right now? But why has this gotten so much worse? The answer lies partly in a chemical messenger that's become infamous in discussions about social media and technology: dopamine. Dopamine is often called the pleasure chemical, but that's not quite accurate. It's more like your brain's motivation molecule, the neurotransmitter that drives you to seek rewards and novel experiences. When you encounter something new, exciting, or rewarding, your brain releases dopamine, creating a feeling that makes you want more. It's the same chemical that fires when you eat delicious food, accomplish a goal, or check your phone and see a notification waiting. Dopamine plays a crucial role in attention and focus. Studies have shown that it helps you shift attention flexibly based on what you've learned is important. It enhances your ability to concentrate, especially when you're engaged in something genuinely interesting or challenging. The problem is that our modern environment has hijacked this system. Social media platforms, apps, and devices are specifically designed to trigger dopamine release. Every notification, every like, every new message delivers a small hit of this neurochemical reward. Your brain learns that checking your phone equals dopamine, so it constantly nudges you to check again. This creates what researchers call the social media dopamine loop. You check your phone, get a small reward, which makes you want to check again soon. The cycle becomes self-reinforcing. And because dopamine is involved in motivation and attention, when those levels drop even slightly, your brain starts searching for the next hit. Suddenly, focusing on your boring spreadsheet seems impossible when Instagram is just a swipe away. The research on this is clear. People who engage in heavy media multitasking, constantly switching between different streams of digital information, show changes in how their brains allocate attention. They become more susceptible to distraction, even when they're trying to focus on a single task. You've probably heard someone brag about their multitasking abilities. Maybe you've even prided yourself on juggling multiple projects simultaneously. Here's the reality. True multitasking, performing multiple cognitive tasks at the exact same time, is neurologically impossible for the human brain. What we call multitasking is actually rapid task switching, and it comes with a steep cost. When you switch from one task to another, your brain has to go through several stages. First, it decides to make the switch. Then it has to unload the context of the first task from working memory and load up the context for the new task. This process takes time and mental energy. Studies from the American Psychological Association found that task switching can reduce productivity by up to 40%. Think about that. Nearly half of your potential output lost just because you're bouncing between tasks. The University of California, Irvine discovered that after an interruption, it takes an average of 23 minutes and 15 seconds to fully refocus on your original task. The brain regions involved in task switching include the prefrontal cortex, which handles attention and focus, and the parietal lobe, which manages the rules for each task. Brain imaging studies show these areas lighting up with activity every time you switch. That activity requires energy. It creates mental fatigue, and it makes you significantly more likely to make errors. Now let's add another factor into this already challenging equation: sleep deprivation. Most people treat sleep like an optional luxury, something you can cut back on when life gets busy. But your brain doesn't see it that way. Sleep is when your brain performs critical maintenance, clearing out metabolic waste, consolidating memories, and restoring neurotransmitter systems. When you don't get enough sleep, your ability to focus takes a direct hit. The effects are dramatic. Sleep deprivation disrupts the balance between different brain networks. Normally, your brain maintains a careful equilibrium between the default mode network, which is active when your mind wanders, and the frontoparietal network, which controls attention and goal-directed behavior. In a well-rested brain, these networks work in harmony. When you need to focus, the default mode network quiets down and the attention network takes over. But sleep deprivation throws this balance into chaos. The default mode network doesn't quiet properly, and the frontoparietal network functions at reduced capacity. Your attention becomes unpredictable. You sit down to work, and your mind immediately starts wandering. You try to concentrate, but it feels like pushing water uphill. Even one night of poor sleep can create symptoms that resemble attention deficit disorder, forgetfulness, difficulty maintaining concentration, and increased susceptibility to distraction. Research measuring brain activity in sleep-deprived individuals shows decreased activity in regions responsible for attention, information processing, and executive function. These are the exact areas you need working at full capacity to focus. The prefrontal cortex, your brain's command center for complex thinking and concentration, is particularly vulnerable to sleep loss. Studies found that creative and innovative thinking, the aspects of cognition that require sustained focus, suffer most dramatically when you're running on insufficient sleep, and quality matters too. Consistently restricting sleep over time does more damage than a single all-nighter. The effects accumulate, creating what researchers call sleep debt, and your cognitive performance degrades steadily as that debt grows. Then there's stress. The modern experience of trying to focus while stressed is like trying to sprint with weights chained to your ankles. When you're stressed, your body releases cortisol, often called the stress hormone. In small doses, cortisol is actually helpful for focus. It increases alertness and can sharpen your attention when you need to respond to a challenge. The problem emerges when cortisol levels stay elevated for extended periods due to chronic stress. High cortisol affects the brain in specific ways. It interferes with the prefrontal cortex, the region that handles complex thought, planning, and attention control. Research has shown that chronically elevated cortisol is associated with reduced performance on tasks requiring memory, organization, visual perception, and attention. A large study following participants from the Framingham Heart Study found that people with higher cortisol levels, particularly women, performed worse on cognitive tests even when they were relatively young and healthy. The mechanism involves how stress redirects your brain's resources. When you're anxious or stressed, your brain enters a kind of hypervigilant state, constantly scanning for threats. This might sound like enhanced attention, but it's actually the opposite. Your focus becomes scattered, unable to settle on any single task because your brain is convinced there might be danger lurking. Attention that should be directed at your work instead gets fragmented across 1,000 different worries and potential problems. Cortisol also affects working memory, your brain's ability to hold and manipulate information over short periods. High stress levels reduce working memory capacity, making it harder to keep track of multiple pieces of information or perform complex mental tasks. If you've ever felt like stress makes you stupider, you're not imagining it. The physiological effects of chronic stress literally impair your cognitive function. All of these factors exist against a backdrop of an environment that's fundamentally hostile to sustained attention. Our modern world is designed for distraction. Tech companies employ teams of engineers and psychologists specifically to make their products more engaging, which is a polite way of saying more addictive. Notifications are carefully calibrated to arrive at intervals that maximize the chance you'll check them. Autoplay features ensure you never have to make an active choice to keep watching. Infinite scroll removes natural stopping points. Every aspect of digital design pushes against your ability to maintain focus. The sheer volume of information available at any moment is overwhelming. Your brain evolved in an environment where information was scarce and attention could be sustained for long periods because there simply weren't that many things competing for it. Now you can access virtually all human knowledge from the device in your pocket, along with an endless stream of entertainment, news, social updates, and cat videos. Your poor attention system never stood a chance. So what can you do about all this? The situation might sound dire, but understanding the problem is the first step towards solving it. Your brain's refusal to focus is a predictable response to an environment and lifestyle that systematically undermine attention. By recognizing the biological and environmental factors at play, you can start making changes. Small adjustments to how you structure your time, manage your devices, prioritize sleep, and handle stress can create significant improvements in your ability to concentrate. The science of attention is complex, but the takeaway is simple. Your brain is doing exactly what it's been trained to do. The question is whether you're happy with that training or whether it's time to retrain it. If you found this video helpful and want to learn more about the psychology behind everyday struggles, make sure to hit that like button and subscribe. Drop a comment below and tell us, what's your biggest focus challenge? See you in the next one.